Hi guys. Like I mentioned in class yesterday, I'm just going to go through some of the basics for you over 2.3 and 2.4, just kind of giving an intro and a kind of a review onto what some things that you guys saw with linear functions in Algebra 1. Okay, so I'm not going to go and do a ton of examples. I am going to do one example, but the rest of them I'm just going to go through and kind of define some things for you just to kind of get your minds working back in the groove with linear functions. Okay, so the first thing I'm going to start with is just the definition of a slope. So we talked yesterday about the fact that if we have a line that's a function, it's non-vertical, and then if we want to write the slope of that line, so generally we say m for slope is equal to y2 minus y1 over x2 minus x1. With obviously y2 and y1 being just the y coordinates of the 2 points you're given, and x1 and x2 being the x coordinates. It does not matter if you do y2 minus y1, or you could also rewrite this as y1 minus y2 over x1 minus x2. Okay, so those do not make a difference. Generally speaking, most of you have used this formula in the past, so if you want to use that every time, do it. The only thing that matters is that you have y1 and x1 starting and y2 and x2 kind of as a second point if you'd like to use this one. So if you want to stick with the tried and true that I just circled, please do so. But really the order in which you do those points doesn't matter as long as you're consistent with your x and y coordinates. So there's a formula for slope, just something that you should know. And if you need a quick refresher on, you have now. Okay, so the next four graphs, what we're going to do is go through and just draw a quick example of each type of slope. So by each type, I mean positive, negative, zero, and undefined. Okay, so positive slope, obviously that means it's rising from left to right. So again, it does not matter where this line is. But that line is going to rise. And so we're going to say that m is greater than 0 because that means that it's positive. Okay. If I want to do a negative slope, I'm just going to have it look like this. So again, that's falling. So that falls from left to right. And the slope is less than 0. Okay, so both of those things you've seen a lot. If a line has 0 slope, that means it's horizontal. So we're going to compare horizontal lines and vertical lines in a second. So that's horizontal, and that slope is equal to 0. And then finally, if the slope, again, this is the slope, is undefined, so m is undefined, that is, whoops, see there's that mistake that I told you was going to happen. Happened early, only 3 minutes in. Okay, so the slope is undefined, there's a D there, and then this is a vertical line. Okay, so underneath here it says, why is the slope of a horizontal line 0? Why is the slope of a vertical line undefined? So we're going to answer those two questions. So when you look at a horizontal line, let's say we're looking at this line, and that looks like 2, 4, 6. Let's say this is the line y equals 6. Okay, so every single y coordinate here is at 6. Let's say that this line is x equals negative 6. So every single x coordinate here is equal to negative 6. Okay, we're going to choose 2 points on those lines, and we're going to prove why the slope is 0. Okay, so I'm going to choose this point. So let's say this is the point 0, 6, and I'm going to choose the point 2, 6. Okay, so if I find the slope between those 2 points, I'm going to subtract 6 minus 6 and 2 minus 0. So that's just using the slope formula from up above. So that is 0 over 2, which equals 0. If you don't believe me, plug that into your calculator. Okay, so that's why that works. When we have a vertical line, we're going to choose, let's say we choose this point. So that is the point negative 6, 0, and we're going to choose this point, which is negative 6, 2. Okay, so again, we're going to find that slope. That's going to be 2 minus 0 over negative 6 minus negative 6. This is like adding. So this becomes 2 over 0. When we have 0 in the denominator, that's when we have issues, right? So that means that that's undefined. So if you don't believe me, if you can't remember, oh my gosh, is 0 over 2 undefined or is it 0? Plug it into your calculator, okay? If it's undefined, it's going to say there's some sort of an error, or the Inspire calculator will actually say undef, so it'll look like undefined, okay? Next on our review is slopes of parallel and perpendicular lines. Okay, so we've seen the different types of slopes, positive, negative, undefined, and 0. Parallel lines, so again, here's your sign. So we're just taking a walk back down memory lane in geometry. So we've got parallel lines and perpendicular lines. Parallel lines are two lines that never meet. So I'm just going to say never meet. In terms of their slopes are the same with different y-intercepts, okay? So here's an example of parallel lines right here. So the slopes are the same, their y-intercepts are different. If the y-intercepts were not different, they would be the exact same line. So that's why we have to kind of define it that way. Perpendicular lines are two lines that meet, so they meet at a 90-degree angle. So that would be something like this. So there's your perpendicular lines. Perpendicular lines, so their slopes are opposite. You could also call these negative, so opposite or negative reciprocals. So whatever, if you like opposite reciprocals, say that. If you like negative reciprocals, say that. That's fine. An example of that is if the slope is equal to 2/3, then the perpendicular line to that is going to have a slope that equals negative 3/2. So opposite sign, reciprocal, flips the numerator and denominator. Okay, so again, that's showing the relationship between the slopes of parallel and perpendicular lines. So far on this page, you've seen formula for slope, the relationships between slopes for positive, negative, undefined, and 0 slopes, and then parallel and perpendicular slopes. Okay, so if we're talking parallel and perpendicular lines in this class, we're strictly considering their slopes. Okay, so we're not going back in time and doing any proofs or anything like that. Okay, if you flip your sheet over to the back, we're going to go through each form of lines. Okay, I'm going to start with slope-intercept form because it's the one you guys know the best. Okay, so y equals mx plus b. M is your slope. B is your y-intercept. I want you to write that as a point, so that'd be the point 0b. Okay, it's best to use when you know, so tips, when you know the slope and y-intercept, okay? Hence the name, slope-intercept form, okay? The other form that I think you guys have seen that you don't use as often that I actually really like is point-slope form. So point-slope form looks like this. Y minus y1 equals m times x minus x1, okay? So in this case, m is your slope, y1 is your y-coordinate of the point you're given, and x1 is the x-coordinate of the point you're given. Okay, so tips for this, you're going to use this when you know the slope, or it's easy to find, and use one point, and that'll be the point x1 comma y1. Okay, so again, your point's going to be coming from here and here. Okay, so I'll give you an example of that in a second. Okay, so that's point slope form. And again, I'm going to suggest that you guys use that a lot more than you're probably used to using it, because I like it. And it's more efficient. Okay, and then I went out of order because standard form is something new that you may have seen in Algebra 1, but maybe not. Okay, so that's what standard form looks like. AX plus BY equals C. For that form, A and B are coefficients. Okay, Okay, so it's not a new variable. You have variables of x and y. And then c, we're just going to call our constant. Okay, so for example, you could have something like this. 2x plus 3y equals 7. Okay, so that would be an equation in standard form. A big tip is this. Okay, we want a and b to be integers. Okay, which means not fractions. So you want to clear any fractions that you have there. Okay, and this is super important. You have to move equation into standard form. So I can't say, hey, here's a point and here's a slope. Put it into standard form. You'd have to put it into a different form and then move it to standard form. And I'm going to show you how to do that in the example underneath here. Okay, so standard form, you guys, is what's going to take the most work because it's brand new. Okay, so for this example, obviously in order to write an equation of a line, you guys need at least 2 points, okay? For point slope form, hence the name, we need 1 point and the slope of the line. I'm given 2 points, all right? But I should be able to find the slope pretty simple, okay? So easily, I guess I should say. Okay, so to find the slope, I'm going to do -3 minus 3 over -1 minus -4. So that's going to become -6 over, we're going to add those, so -1 plus 4 is 3, so the slope is -2. Okay, so I have a slope that equals -2. In order to write this in point slope form, which I want you to do first, I'm going to choose 1 point. If I look at both of those points, I'm going to choose -4, 3, just because it only has one negative value. That's the only reason. If you want to choose -1, -3, that is totally fine. Okay, so here is our general form. Oops. So we're going to plug in what we know. So we're going to have, gotta stop switching colors. Y minus the y coordinate. So in our case, again, I'm using -4, 3. So that's my y1. So y minus 3 equals the slope, which is -2, right here, times x minus my x coordinate, which is -4. So that's going to be x minus -4. Okay? If you want to leave it like this, you can. Here's how I would normally write it. -2 times x plus 4. Okay, so when we have more time, I'm going to go through and kind of explain, like, this +4 makes it look like the point is actually positive, but it's negative. So we'll kind of go through and see some patterns as you're working. Okay, so there's point slope form. My suggestion for you is to work straight into slope-intercept form. So could you work backwards and find the slope and solve for the y-intercept? Absolutely, but my suggestion is to use what you already have and distribute. So this would be y minus 3 is equal to -2x minus 8. Okay, since we already did that work, we might as well let it help us. I'm going to add 3 to both sides. Y equals -2x minus 5. So there's our equation in slope-intercept form. Okay, then we're going to use our equation in slope-intercept form to rewrite it in standard form. So on the tips, I said, hey, you know what, standard form, you can't just put something into that. You have to move your equations into that form. So in order to do that, again, I need my equation to look like this. So basically what we need are x's plus y's on the left side equal to my constant. Okay, so from my slope-intercept form, all I'm going to do is add 2x to both sides. So by adding 2x to both sides, then I'm going to end up with this equation. 2x plus y equals -5. And that is in standard form. Okay, so tomorrow whenever we're back, I'm going to go through and kind of re-explain this stuff and just kind of show you some applications of it to make sure that you understand when and why we would be using this. But if you've got the gist to go from point slope to slope-intercept to standard form, then you're going to be ready to roll. Okay, have a great day. You should be working on your homework after this, and you can work together and ask questions from Mr. Ray. Have a good one.